Welcome to Macmo Academy. Dear students, in this video we will understand graphs of motion. When we talk about rest and motion, so as you already know that motion means that changing your place from or your position according to your surrounding from one point to another. So there are few terms that you already know related to motion, which are distance, speed, time, and acceleration. So when we talk about graphs of motion, so there are total two types of graphs of motion. One is distance time graph, distance time graph, and the second one is velocity time graph. So one by one we will understand what is mean by distance time graph and what is mean by velocity time graph, and we will see that how to draw the graphs related to the data when it is given. Means we will understand here that how to draw them or sketch them. And the second thing that we will understand is interpretation. When the graph is given to you and the questions are asked, so how will you read the graph and how will you answer the question? So before doing the questions of this topic, you need to understand that how the graph will look, in which condition the line will be straight, and what type of line will be drawn on the graph, or what type of line is showing the type of the motion, that is it accelerating or not, is it uniform speed or not, or the object is at rest or not. So that's what we will discuss first. So when first of all we will discuss about distance time graph. So you know that it's graph, so you must have x-axis and y-axis. So whenever we talk about distance time graph, so as there are two quantities, remember, time is independent quantity, means that time will not stop. It will continue on and it will run continuously. So you will always plot your time on the x-axis. So in distance time graph, the time will be always on x-axis and distance will be always on y-axis. Right now, I'm not taking any particular value, but here I will tell you one or very few important terms related to the distance time graph. First of all is you will put your distance on y-axis and your time on x-axis, and whenever on distance time graph you will see a horizontal line. What does it show? If you will look here, so according to this horizontal line, the x-axis is continuously moving. The x-axis is continuously moving. But what about y-axis? Y-axis value is not changing. Y-axis is actually the height. So you can see here there is no height of this particular line. Or in other words, the gradient or slope of this line is 0. So you must know all the vocabulary or all the words. Not only the word horizontal line will be beneficial for you, you must know about this word as well, slope or gradient. So whenever on distance time graph your slope is 0, means your line is horizontal, it indicates that your object is at rest. Why is that so? Because your value of distance is not changing, you are not covering any distance. So whenever you don't cover any distance, it means that your object is at rest or the body is at rest. So whenever distance is 0, and distance, sorry, not 0 mean not changing. Right now the distance is not 0, maybe an object is started moving and then after covering some distance it stops, so it is not changing, distance is further not changing. So whenever it is not changing, it means that object is at rest. And what does it mean? That the line will be horizontal line. And the other word is slope is 0. That's what horizontal line on distance time graph means. Now what will happen if we will have a line like this? Now if you will look at this line, it is showing that the distance is changing, okay, with respect to time. Okay, so there must be some slope of it. Now the slope is not equals to 0. It must have some value. So what does it mean? Very important thing. Right now it means that object is moving, and the object is moving with constant speed. That is very important. You already know about what is mean by constant or uniform speed or velocity, or you know about it, that what is mean by non-uniform. So whenever the object is with constant speed, its acceleration is 0. Right now the acceleration is 0. Okay, so whenever in distance time graph you will see a horizontal line, it means that the object is at rest. It means that the speed or velocity is 0. And whenever you have a slope line, it means that the object speed is constant and the acceleration is 0. Now distance is changing. Okay, so that's what it means. And then, and one more thing over here is not only constant speed, but it is increasing speed. The speed is increase and it becomes constant, right? And again, it could become on rest and you will get a straight line. Again it becomes at rest. Now it will go down like this. So what does it indicate? What does this indicate? This is also constant speed. This is also constant speed. But now the what happened when the line is going down? So this is also indicating that the speed is constant. That the speed is constant, right? Speed is constant over here. But now if the speed is not constant, how the graph will look? So over here we will make another simple example of the graph to show you that how the graph will look if the speed is not constant. So same graph, distance and time. Okay, now if you will have a line which is curved line like this, it is a curved line, and one line is like this, it is not curved, it is straight. So whenever you have a straight line, it indicates that the object is constant, as we have already seen in this graph. But whenever you have a curved line, it means that the speed is not constant, it is non-uniform. It is non-uniform. Means there will be some acceleration. There will be some acceleration. So from here, after this understanding, we understood that whenever you have a distance time graph, so a horizontal line is showing that, or the slope is 0, is showing that the speed is 0, the object is at rest. Whenever you have a slope line, straight line, it shows that the object is moving but with constant speed. And whenever you have a curved line, it shows that still the object is moving but not with constant speed, it is non-uniform speed. And during this one, acceleration is generating, means there is some acceleration. But in the straight line, as I have told, that acceleration is 0. One thing that I want to tell over here related to the representation of distance time graph, and that is very important as well, is that, for example, you have two graphs of distance time, and the scaling is same for both. But on one graph, your line is like this. What will you comment on the speed? The speed is constant. But on the other graph, your line is like this. And I said that the scale is same. Means the numbering on the graph is same. So what does it mean? That they both have constant speed. They both have constant speed. But in graph B, or the object B, I can draw it on the same graph as well. For example, if I will draw this line on this graph, it will look like this. So it is for the comparison. So if you will look at this black line and at this red line, both lines are showing the constant speed. But the more steeper the line or the more slope the line is having, more speed or greater speed. Or slower object. Okay, so if the line is more steeper, if the constant or if the slope or gradient is high, it means the object speed is greater than the line which is showing the less slope. And you can understand why is that so, because it is showing that more time is consuming for a particular distance. Let's say one more line. So if you will compare these three lines, the greatest speed or the highest speed object is this one, and then this one, and then the with low speed, lowest speed. So more gradient means more speed, less gradient means less speed. So these are some terms related to distance time graph, right? And remember that curve point, whenever you have a curved line on a distance time graph, it is showing that the object speed is not constant and it is generating acceleration. Now let's discuss velocity time graph. In this video, we will understand only the look of the graph, that if there is a line like this, so what does it mean? In our next video of this series, we will understand the questions related to it, in which we will draw the graph, in which we will interpret the graph. So let's understand velocity time graph. So when we say velocity time graph, we have again time on x-axis and speed or velocity on y-axis. And one more thing that you need to understand, that there is no distance. We are not showing any distance over here. So first of all, let's say the condition, if the object is at rest. So when the object is at rest, it means that the velocity is 0. So the line will be on x-axis. The line will be on x-axis because there is no velocity. So that's the difference between the speed time graph and velocity time graph, that when the object is at rest in a speed time graph, you show the line could be at some point over here as well. But when you talk about at rest and it is velocity time graph, so the line will be on x-axis, that is representing at rest. Now, if an object is moving and the velocity or speed is constant, how will the line look? The line look will be horizontal line. For example, an object reached at this particular point of velocity, and then now it is velocity is not changing. Okay, so this point is showing, or this line is showing the constant velocity, and at this point the acceleration is actually 0. Now let's say if the object's velocity started increasing, so you will get a slopy line. Or line with slope, like this. So it is not showing the constant velocity. Remember, in distance time graph, the straight line with some slope is showing constant velocity, but in velocity time graph, the straight line with some gradient or slope is not showing constant velocity, it is showing non-uniform velocity. So slope not equals to 0, straight line showing non-uniform or non-constant So what does it mean? That the slope of velocity time graph shows acceleration. If there is no slope, means there is no acceleration, as we have written in the first point. That constant velocity means acceleration is zero, and horizontal line indicate that the slope is zero. But if there is some slope of the line, it shows that there is some velocity. So slope of velocity time graph shows acceleration, right? Now what will happen again if it will go for the constant speed? So it is increasing speed. One more word for this is increase. If the slope is getting positive, it is increasing speed. But what if you will go down? It means that the object applied the brakes and its speed is going down and becomes zero. So this is negative slope. It is showing there is acceleration, but this is decreasing speed. This is decreasing speed. So you can see for one particular line there are multiple wordings or explanations. That's why in interpretation you will need these wordings. For example, if I will take only this portion, so this line is actually showing multiple things. First thing is this line is showing is that right now the motion is not uniform velocity, it is non-uniform velocity. Means there is some acceleration. Other than this, it is showing that the object speed is increasing. And then straight line is not only showing you that the object is velocity is constant, but it is also showing you that the acceleration is zero. And then the downward gradient is showing you that the speed is decreasing, and this in this particular scenario, actually you don't call it acceleration, you call it deceleration, the opposite of acceleration. So whenever the speed is increasing, you call it acceleration. Whenever the speed is decreasing, you call it deceleration. Now one more important thing that I want to discuss here related to velocity time graph is that area under the velocity time graph, and we will do the questions related to it in detail of each and everything. So if you are stucking somewhere or if you have any confusion, it will get clear in those videos when we will do questions. In this video, we are just understanding the terminologies or the representation that which line is showing what. Alright, so if you have a velocity time graph and it looks like this, for example, object's velocity is increasing and then it went for a constant velocity and then again it's decreasing and becomes zero. Now if you will look over here, it is a shape. Okay, it is a shape, and this shape is actually trapezium. In this whole scenario of velocity time graph, we did not talk about the distance. So here I am telling you about distance. To find or calculate the distance of the journey or the motion, what you need to do, whatever your graph looks, for example, in this particular example, your graph looks like a trapezium. So you need to find the area of this shape. Or right now it is trapezium, so you need to find the area of trapezium. We will do the questions related to it. So that's why I'm not going in depth that what is the area of trapezium, how to calculate it. But I'm just telling you one thing over here, that if you want to find distance from velocity time graph, you actually need to calculate area. However the graph is showing to you, you will calculate the area of that particular shape. It will be counted as distance of the motion or the journey, and it depends on the shape. Sometimes it is trapezium, sometimes it looks like a rectangle, maybe anything, or maybe a triangle. So we will see that in our video related to the calculation of distance from velocity time graph. Right now in this video we have understood that how distance time graph and how velocity time graph is showing you constant velocity, acceleration, object at rest, object at motion, increasing speed, decreasing speed, and which line is showing which category. So that's what we have understood in this video. In our next video related to this series, we will understand that how to draw distance time and velocity time graph and how to interpret them, and questions related to it. Thank you for watching the video. If you have any confusion, you can ask us. And if you like the video, don't forget to subscribe our channel.